So my study is Branksome Chine Beach more stable than Cranford Cliffs Beach? So I found that beach stability refers to the ability of a beach to maintain its shape and size over time, which I looked at over 6 years of the width. And because it changed from season to season, I chose to only look at spring and summer months. So these are the driving factors that will affect those rates. So first of all, erosion, worldwide issue, but Bournemouth continues to decline by 1 metre every year. Sediment supply, onshore and offshore, we need to know for the equilibrium where to put sand if we need it, and where we can dredge from. Um, Shoaling will alter beach morphology, so we need to look at that. Human activities, beach nourishment schemes, and dredging, so that will alter onshore and offshore sand sediment supply. And coastal engineering, we need to know where to put groins, and it will also change deposition and erosion patterns. It's important. Coastal protection, we need to know the erosion rate, so we need to know if our mitigation strategies are working after we implement them. Tourism, we need to take care of our beaches because they're popular destinations to bring in money, and infrastructure planning for current roads, hotels, residencies, and new ones to know where we can put groins, seawalls, where we can help the beaches. So this is where I collected my data on Branksome Chine Beach. So I had a 6 metre long transect to start with, then I divided that up into 6 100 metre transects, and I used aerial footage using Google Earth Pro to find my data. This is where I did it for Cranford Cliff Beach, which is exactly the same, 6 100 metre long transects. Collected the data using aerial satellite images from Google Earth Pro, obviously with the 6 transects at the 2 different beaches. I used the high water line to the promenade and measured each transect 1 to 6 to get an average, and then I put it into a table at what date the measurement was taken. So this was the first table that I set up from Branksome Chine, so it's just where I measured it, and I got the averages at the bottom of the average beach width for that beach, for that time, sorry, and then on the right, the average beach width for each transect, so how much that transect changed. I did the same here for Cranford Cliffs, so you can see at the bottom. So this is the table that I put it in to make it a little bit more clearer. So this is the rate of change between the time frames. And then I highlighted to see whether from the time before it grew or shrunk, but we'll come back to that. And the same here, the rate of change in meters from each time frame, but this time I highlighted whether the beach width had increased or decreased. Using the data that I found that the average rate of change per month for Branksome Chine was 0.55 meters per month, and per year that is 6.54. Cranford Cliffs average rate per month was 0.71, and then average change per year was 8.55 meters per year. So the difference is about 2 meters. So Branksome Chine changes less, which means it's more stable. The average rate of change in meters per month for the beach width, according to the timeframes given, so Branksome Chines and Cranford Cliffs. So Branksome Chine average change per month for these timeframes were 0.55 meters, and Cranford Cliffs was 0.71 meters, which is obviously higher. So although Cranford Cliff is positive because it's increasing in size, therefore it is better, Branksome Chine is averagely changing less, which makes it more stable and less likely to fluctuate. So this is just a box plot of my data at Branksome Chines, but we'll come back to that. And the same for Cranford Cliffs here. This shows the average range and the average mean, which is lower at Branksome Chine, therefore is more stable because it changes less during these months. And overall, Branksome Chine changes less, so yes, it is more stable than Cranford Cliffs. Here's the limitations for my study. So Google Earth Pro doesn't carry consistent data, so they don't have all months and sometimes not all years. So I found that 2021 had no data at all. So I had to fill in using an average, but that made it difficult because some years had less time in between the rate of change. So I just had to use an average, which obviously isn't consistent. I only did spring and summer months, but that doesn't take into account the winter months, which have more destructive waves and more erosion and more storms. So the data actually came out being positive, increased in size when that is not actually how it is all year round. However, the winter months didn't have enough data for me to do. Human activity interferes, so I could have just done my study straight after people put more sand in the beach from beach nourishment. and the averages will not be reliable due to the time frames. So every month is not going to be the same.